Chapter 2, Section 5. We're going to learn now about solving for a variable. In fact, you're going to hear this a lot in upcoming math classes that you take. You're going to hear it in physics. You could hear it in biology. Solving for a variable is something that you need to learn. It is the way that you do a lot of math calculations. So take note of this. Make sure you get this down. This is very important. Now, when we solve for a variable could be x or y, or it could be m or n, or any other letter we might give it. In this case, I'm going to give you an example of x plus y. Let's say equals 10. And I'm going to say, let's solve for x. In this case here, what I want to do is I want to come up with something that says x equals something over here. Now, it means I only have the x here. There's only an x on one side of this equal sign. Here's my equal sign right here, and it's only the x that sits there. All right? So that's what I'm trying to do. Now, in this case here, where we're looking at the x plus y equals 10, what we would do here is we would subtract the y from both sides. Let's just subtract the y over here. All right? So that it would eliminate here. And what are we left with on this side of the equation, or this side of the equal sign? All we're left with is x. And in this case, it would be 10 minus y. Now that's very simplistic. That shows you how I got it down to saying just x on one side. That's what I was looking for. And now I've solved this equation for x. Let's take a look at another example. Let's say we had something like this. Let's say it was x plus y plus 5 equals 0. And I wanted to solve again for x. Now this time, I have to bring two different entities over to the other side of the equal sign. I got to bring my y over and my 5 over. So I got a plus y here, so I'm going to subtract y from both sides. I have a plus 5 here, so I'm going to subtract 5 from both sides. These end up canceling out, and what I'm left with is x equal to negative y minus 5. I've solved for x. All right, that's pretty easy to see, hopefully, what we had to do to get x all by itself. Let's take a look at another equation. Let's make this just a little bit harder now. And I'm going to say x minus 2y equals 3y minus x. It's a little bit more difficult now, right? Because now we have variables on both sides of the equal sign. Well, let's see how this would work then. If we were going to do that, I want my x's all by itself. Well, I've got an x and a y on this side, and I have an x and a y on this side. But I want you to notice, this is how I look for it. Where can I stay with positive x's? Well, obviously on this side, because I'd have to add an x here and add an x here, right? And if I add those two together, I would come up with 2x here, and this would actually turn out to be 0. Well, if you notice, if I brought my x's to this side, I need to bring my y's then over to this side. So let's add 2y here and add 2y here. Notice I put them underneath the y's, just like I did with the x's. In this case here now, my y's cancel. Minus 2y plus 2y is 0, just like my x's canceled over here. Now I have 3y plus 2y would equal 5y. So if I was going to rewrite my equation again now, my equal sign is right there. I could write it as 2x equals 5y. But am I done? No, because I have 2x here. I don't have just x. Well, if you notice, 2x is really 2 times x, right? So if we're multiplying by 2, then let's divide both sides by 2. All right, do the opposite. And in this case, my 2's would cross out. It would actually be 2 over 2 is 1. But we don't have to show that in front of an x, do we? We can just label it as x, and we're left with 5/2 y. Well, then x equals 5/2 y. And now I've solved for x. Notice all I'm left with here is my x value. And that's what I'm looking for. That's how we solve for x. All right, let's take this a step further. We've learned how to solve for a variable. So if I told you how to solve for, I wanted you to solve something for x, you know how to do that now. We get x, only the x variable on one side of the equation. Let's take a look at how we put numbers in for the other variable to find out what x could be, or let's say y could be. Let's try this. Let's try, let's say 2x plus 3y equals, let's say 9. I'm going to just give a nice answer there. I'm going to solve for y this time. Okay, now this is the same as what we did before. We only want the y on one side of the equation. All right, not anything to do with the x over on this side of the equal sign, let's say. So if that's the case, I need to get rid of my 2x. Right now I'm adding 2x to this equation on this side, right? So I would need to subtract 2x from both sides of the equation. That eliminates this right here. 2x minus 2x is 0. And we're left with 3y equals 9 minus 2x. Now if you notice, what are we left with over here? We're left with 3 times y. Now to get it down to where it's just y, where it's 1y, we have to make this a 1 in front. Well, the only way we do that is to divide this by 3, right? Make it 1y. So that means we divide this by 3 and we divide this by 3. Each one on the other side. And now what we're left with, 3 over 3 is 1, which would just leave us with y. And our 9/3 is really broken down into 3, right? 3 goes into 9 3 times, minus 2/3 x. Now here's the fun part. We're going to put a value in for x right here. We're going to say x equals, let's say, well, let's pick an easy one, 0. What would y equal then? All right, if we were to look at this equation right here where we said x equals 0, we could write it like this. Y equals 3 minus 2/3 times 0. We replace the x with 0. And what do we get? Well, anything times 0 is 0, right? So we would end up with y equals 3. That would be our answer. If x equals 0, then y equals 3. That's how we can substitute a number in for one of the variables and find out what the other variable is. All right, solving for a variable has been pretty easy up to this point. You know, we've easily brought variables or numbers to the other side of the equal sign to get either an x or a y by itself. But what about if we did it a little bit more difficult? Let's say we had something like this. X equals, let's say, n plus p over y. And I told you that I wanted you to solve for p. In other words, I want you to have something where it says p equals, and that's the only thing on that side of the equal sign. Well, we have to do a little bit more in this case, because if you notice where p is, it's sitting up here, and we just can't move everything around easily to get p by itself. Oh, we can, actually. If we notice first, we always take care of alone or by itself or whatever's easiest. We try and simplify down what's there. And if, in this case, if you notice, we're dividing by y on this side of the equation. Well, what I can do is I can multiply, let me not make an x, let me make it look like this. Multiply by y on both sides of the equation, right? If we're dividing by y and then multiplying by y, it is 1, right? It's just y over y, which is 1, so these two would actually cancel themselves out. And we would be left with, I'm going to rewrite this, I'm going to put an xy, just flip them around, and It's the same thing. And then it would be n plus p. Now, does that look a little bit easier to getting p by itself? It should. All we have to do now is pull this n over to the other side of the equation. Well, that means we're adding n here, so we need to subtract n from both sides of the equation. And what does it come out looking like? Well, our n's cancel out. This becomes 0. We're left with p over here. I'm going to get that 0 out of there. We really don't need it. And we're left with x, y minus n. So our final equation is p equals x, y minus n. And that's how we solve for p. Now that was kind of funky. We had to do a little bit on that one to get it, figure it out. We had to look at opposites and bring that y over first. So a little bit different, but it's not something that's not solvable. You can do this. And you'll find that anytime that I ask you to solve for a variable, you can do it. I'm not going to give you one that you can't do it or it doesn't work. It's always going to work. Let's try this one here. Let's try xp plus yp equals z. All right? Uh-oh. How do we add an xp and a yp? Well, we can't. Those are two separate variables, right? They're two completely different numbers, but they do have a p in common. In this case here, watch what I can do. I can take a p out of both of these, right? And I can put something in parentheses around it. Well, if I divide this by p and this by p, all right, in other words, take it out, make it 1, I would have to put a p out in front of this. I'm taking a p out of both of these, and what I'm left with then is x plus y. All right? And this equals what we've done on the other side is z. Now, does this work? Well, sure. Remember the distribution process? If I brought my p through to my x and p through to my y, I would end up with xp plus yp. So yeah, I can just take those out and then put the p out in front of the parentheses. Looks a little different. This might be a little hard to look at if I say divide by p, but if you think about it, that's really all I'm doing. I'm dividing by p on each side, and I'm putting, this goes 1, this goes 1, and I'm putting the p out in front of the parentheses. Okay, that's how we can look at it. Now, I'm solving for p in this case, so what would I have to do? Remember, I want p by itself, looking like this. Well, this is p times x plus y, right? What if we divided both sides by x plus y? What would happen? Well, we would cancel this out, right? That becomes 1. What are we left with on the other side? Z over x plus y. And now we've solved for p. A little more difficult. It's adding in a new step of being able to solve for a variable, but it's something that can be done, and it's something that you guys can do too.